Thank you so much for coming to my virtual talk. I'm really excited to talk to you today about the evolution of body shapes in reef fishes. So my name is Katherine Corn. I'm a sixth-year PhD candidate at UC Davis, and I study the multi-million-year processes that underlie the incredible diversity of reef fishes that we have alive today. So reefs are renowned for their biodiversity in many axes: fish color, many species. But one way that reef fishes are really special and unique is that they've evolved a novel mechanism of prey capture that is almost completely absent from fishes in the rest of the ocean. So most aquatic vertebrates capture their prey using suction feeding. And suction is a really flexible feeding mechanism. Suction it's uniquely aquatic. It relies on the density and the viscosity of the water to pull in water and prey item. And the way that the animal does that is by rapidly expanding the head and jaws, creating a low pressure region inside the head, and then pulling in that prey. And so I'm going to show you a video here of what that looks like. So I'll show you a grouper. And what you're going to see is the grouper on the left will swim across the frame to suction in this unsuspecting zebrafish in the middle. And so what you can see is that this is a really dynamic feeding process made possible by the rapid expansion of the head of the grouper. And suction is really special because you can capture almost any mobile or free swimming prey in the ocean with it. And that's why it's so popular. Suction is used by turtles, it's used by aquatic birds, it's even used by whales. Suction really spans the diversity of aquatic vertebrates. But if you look at a coral reef, you can see that there are lots of things on reefs that are not easily suctioned in by a hungry critter. And so these are typically prey items that are attached to the surface of the reef. So that's going to be things like algae, corals, and sponges, lots of things that require direct actions from the jaws of a predator in order to scrape or graze or yank that prey item from the reef surface. So what I'm going to show you here is a video of a parrotfish, and the parrotfish is going to approach the feeding block, and then remember that suction feeder expanded his head and jaws, what you're going to see the parrotfish do is instead apply compression through the jaws in order to scrape the algae off of the block. And so biting is a totally different functional process. And you would think maybe that all attached prey are the same. Everything requires the direct force to be passed through the jaws in order for prey capture. But what's really amazing about biting, and what we have realized through our time working with these biting fishes, is that biters actually prey on an incredibly diverse range of prey items. So biters can eat algae, they eat sponges, they eat corals, they eat little snails that have attached themselves firmly to the reef surface. They even can eat these scales off of other fishes. And so biting results in this incredible functional diversity. And what we have found through our work in the last few years is that this functional diversity of biters has resulted in amazing phenotypic diversity of biters. So biters actually evolve body shapes almost twice as fast as suction feeders because their prey are so functionally diverse. And what that means, when you look at the distribution of body shapes that biters have not only evolved body forms that are uniquely modified for biting, so very deep bodies that allow them to traverse the structurally complex habitat that they live in, but also they've evolved many of the same body shapes that suction feeders have. This is incredible. And we wouldn't have been able to do this work without the support of ARCS. I'm so grateful for your financial support and support as a developing scientist over the last few years. So thank you so much.